Good morning to one and all. Now we have to see the topic test of hypothesis in mathematical statistics. Statistical hypothesis. Statistical hypothesis is some statement about population. Statistical hypothesis is of two types. A hypothesis is simple if it specifies the population completely. Otherwise, the hypothesis is said to be composite. Components of formal test of hypothesis: null hypothesis, alternative hypothesis, test statistic, critical value, level of significance. Null hypothesis. Null hypothesis is a statement about population parameter. Parameter means the characters of population, that is mean, median, standard deviation of population. So H0 null hypothesis is a statement about population parameter. Alternative hypothesis means a statement that directly contradicts the null hypothesis. Test statistics is the value calculated from the sample data. The sample is drawn from the population sample data that is used in making a decision about the rejection of null hypothesis. Critical value is the value that defines the rejection zone. Level of significance is denoted by alpha. It is the probability that the test statistic will fall into the critical region when the null hypothesis is true. Then types of error. Basically, there are two types of errors, type 1 error and type 2 error. How will you detect the type 1 error? Type 1 error means rejection of H0 when it is true. That is, rejection of null hypothesis when it is true is type 1 error, and it is denoted by alpha. Type 2 error, accepting H0 when it is false. Then it is a type 2 error denoted by beta. Rejecting the null hypothesis when it is true, falling to reject the null hypothesis when it is false. So alpha equal to probability of type 1 error, beta equal to probability of type 2 error. False negative test equal to type 1 error, false positive test equal to type 2 error. The symbol alpha is used to represent type 1 error. It is also denoted the level of significance also. The symbol beta is used to represent the type 2 error. As alpha increases, that is type 1 error increases, then type 2 error decreases. As type 1 error decreases, then type 1 error increases. As a sample size n increases, both alpha and beta, that is type 1 and type 2 error decreases. Graphical represent relation between type 1 and type 2 error. This is null hypothesis curve. This is alternative hypothesis curve. The straight line is power of the test. This is type 2 error. This is type 1 error. Key difference between type 1 and type 2 error. In statistical hypothesis testing, type 1 error is caused by disapproving a null hypothesis that is otherwise correct, while in contrast, type 2 error occurs when the null hypothesis is not rejected, even though it is not true. Type 2 error is same as a false alarm or false positive, while type 2 error is also referred to as false negative. Type 1 error is represented by alpha and type 2 error is represented by beta. The level of significance determines possibility of the type 1 error, while type 2 error is the possibility of deducing the power of the test from 1. Deducting the power of test from 1. You can decrease possibility of type 1 error by reducing the level of significance. The same way, you can reduce the probability of type 2 error by increasing the significance level of the test. Type 1 error occurs when you reject null hypothesis. In contrast, type 2 error occurs when you accept incorrect outcome of false hypothesis. So type 1 error means the rejection of null hypothesis when it is true. Type 2 error means acceptance of null hypothesis when it is false. Type 1 error is also called false positive. It is false negative. It is denoted by null hypothesis is type 1 is and type 1 error, alternative hypothesis and type 2 errors. How to avoid type 1 and type 2 error? For type 1 error, minimize the significance levels to avoid making errors. So, minimizing alpha means type 1 error can be avoided. Type 2 error can also avoided if the significance level of the test of hypothesis is chosen. By choosing alpha, that is level of significance, we can avoid type 2 error also. Does the sample size affect type 1 error? Small or large sample size does not affect type 1 error. So, sample size will not increase the occurrence of type 1 error. Only principle is that your test has the normal sample size. If the sample size is small in type 2 errors, level of significance will increase. Therefore, reducing type 1 error comes at the expense of increasing the type of error. The same means cannot reduce both type 1 and type 2 errors simultaneously. Power of the test. Type 2 error is denoted by beta is the probability of falling to reject a false null hypothesis. 1 minus beta is probability of rejecting a false null hypothesis. The probability is identified as the power of the test. The probability that a fixed level alpha significance test will reject H0 when a particular alternative value of the parameter is true is called power of the test. So, formula for power of test is 1 minus beta. Most powerful test. A critical region W is the most powerful critical region of size alpha and the corresponding test a most powerful test of alpha for testing H0 theta equal to theta naught against H1 theta equal to theta 1 if probability of x belongs to W such that H0 equal to integral over W L0 dx equal to alpha and probability of x belongs to W such that H1 greater than or equal to probability of x belongs to W1 such that H1. For every other critical region, W1 satisfying equation 1. Uniformly most powerful test. A test defined by the critical region C of size alpha is uniformly most powerful test if it is a most powerful test against each simple alternative in the alternative hypothesis H1. The critical region C is called uniformly most powerful critical region of size alpha. What is uniformly most powerful test? It is denoted by UMP. A test defined by the critical region C of size alpha is uniformly most powerful test if it is the most powerful test against each simple alternative in alternative hypothesis. The critical region C is called the uniformly most powerful region of size alpha. Likelihood function. If x1, x2, etc. xn is a random sample of size n from a distribution with the probability density function or probability mass function, then the joint probability density function of x1, x2, etc. xn is denoted by likelihood function L of theta. That is joint probability function or mass function L of theta equal to L of theta comma x1, x2, etc. xn, which is equal to f of x1 comma theta into f of x2 comma theta etc. f of xn comma theta. The likelihood L of theta still depends on sample data only. Neyman-Pearson lemma. Suppose we have a random sample x1, x2, etc. xn from the probability distribution with the parameter theta, then if C is critical region of size alpha and K is constant such that L of theta naught divided by L of theta alpha less than or equal to K inside the critical region C, and L of theta naught divided by L of theta alpha greater than or equal to K outside the critical region C, then C is the best, that is most powerful critical region for testing the simple null hypothesis H naught theta equal to theta naught against the simple alternative hypothesis H A theta equal to theta 1. This is statement for Neyman-Pearson lemma. Thank you.